Quiz this Thursday. It's going to cover sections 3.5 to 3.7, so let's go over a few things. Starting in section 3.5, we talked about direct variation. What do you remember about direct variation? What kind of, stood out to you? Are any of these graphs here in orange, do they reflect direct variation? Which? Yeah. Good, B and C. What has to be true? How come this one isn't direct variation? Yeah, for direct variation it has to go through the origin, so the first one's not, second one is, third one is, so it has to go through the origin. Great. Let's think of a few examples. A, B, C, D, or A, B, C, and D. Which of these are going to pass directly through the origin? How about the first one? Is that going to pass directly through the origin? With direct variation, you're really talking about the equation of a line, but if it passes through the origin, what has to be the y-intercept? 0. Does this have a y-intercept of 0? Is that the same function? So it has a y-intercept of 0. If it has a y-intercept of 0, it is an example of direct variation. How about the next two? Yes? How about this one? No. All right, so a yes and a no. How about the last one? Well, it's different variables, but do I have like a plus something here? It's a plus 0. So these two vary together directly because this would pass through what would be the equivalent of the origin in this different scale, C and G. G would be the independent, this would be the dependent. So yes, it would pass through. There's also another feature. If you double the amount of the independent variable, what happens to the amount on the dependent variable? It doubles. So if you put in a 2 here, you get 10 here. If you put in a 4 here, you've doubled the 2, you're going to get 20 here. So double on one side is going to double on the other side. Which one of these are likely to represent direct variation? Gallons of gas and cost? Mm-hmm. Yeah. Is there a y-intercept there? How much does it cost to get 0 gallons of gas? $0. So it's passing through the origin. So we've got direct variation there. How about here? Do we have direct variation here? No. Why not? There's a pickup fee. So that means that graph is not passing through the origin. So you have a linear relationship but not a direct variation. Okay, so good for that part. Let's take a look at section 3.6. And quick, cheap little public service announcement here. Where is it? Come on, there we go. Yes, OCC is having a Throwdown Square Dance this Friday. So come by. They'll actually teach you some moves that you need to know, give you some snacks, and there'll be a DJ. So check it out. Student Council has an arrangement with Hungry Howie's to buy pizzas at $8 each. The council wants to spend at most $164 on pizza for the Throwdown Square. Write and solve an inequality for the number of pizzas that can be purchased. All right. Well, we've got $164 on one hand, and we've got 8 times the number of pizzas on the other hand. Now you've got a couple choices for your inequalities. You could have a less than or equal to, or a greater than or equal to. But you want to make sure that you're spending at most 164. At most 164. So which inequality guarantees that your cost is going to be at most 164? Do I want to write the less than or equal to or the greater than or equal to? Ooh, some disagreement there. Do I want this to be more than 164 or less than 164? Less. And remember, the alligator eats the smaller number, right? So that would put the pointy end here. So it'd be a greater than or equal to. We want this to be greater than the amount that we spend. Yeah, no, that's why I wanted to go over this one. It's easy to get that flipped around. Yeah, we don't want to spend more than 164. We want that 164 to be more than what we spend.
Okay,
So we're spending at most this much. We can't spend more than this because this is going to be greater than our cost of eight pizzas.
okay, so it would be. I get it, but I'm confused too because in
Sure.
my mind, if you don't want to go over that, then you would spend either 164 or less than 164.
Tell you what, let me put it a different way. Let's just reverse those roles. Put 8p here and 164 here. It's the same two things, but here, if you want to spend at most this much, now the inequality is going to run this way. That here's how much you're going to spend, or here's your budget. You're going to spend less than that much. It might be easier to think of here because now we could say, all right, this is how much it's going to cost, and that's at most 164. So we've got less than that amount there. So it might be easier to put the variable part here and the number part here. Now, let's see. There was part 5 on that. It says write an equation that shows the cost if there's a $15 delivery charge for the pizzas. So that means our cost is going to be not only the pizzas, but then the $15 delivery charge. What should I write here? Plus 15. Now, if you have to pay that delivery charge and keep the number of pizzas to a sufficient amount so we don't blow our budget, then we would want to solve 8p plus 15 is less than or equal to 164. I could actually solve that. So minus 15 on both sides. 8p is less than or equal to 149. Divide by 8. P is less than or equal to, that's going to be some fraction, I think. 149 divided by 8, 18.625. Now this is kind of like a problem that we ran into on the board. Can you buy 5/8 of a pizza? Typically, no. I'm not going to slice it up for you. So what should I choose so that I don't go over budget? Yeah. So choose P equals 18 so that you don't go over budget. Nice. One other reminder while I'm here, if I had negative 2p is greater than or equal to, let's do 18. What's the thing you got to remember about solving something like this in terms of an inequality? Yeah, when you divide or multiply both sides of an inequality by a negative, you need to reverse the direction of the inequality. So that would be that. The graph of something like this would be a solid dot on the negative 9. Which way do I draw the arrow?
This way.
Layla? So the nice thing about putting the P on the left-hand side is it tells you which way to draw the arrow. So it's going to be to the left. You're looking for numbers that are less than negative 9. Less than numbers are to the left. Bigger than numbers are to the right. So even if I wrote this as negative 9 is greater than or equal to P, it's still the same inequality. It still tells you to graph numbers that P is less than that, numbers to the left. All right, I think we got one last little one to tackle. That's this one. Texas Instruments can produce calculators, 400 calculators for a profit of $2,000. Should probably put a little dollar sign there. Let's see if we can't figure out an equation for this. Each calculator costs $80. So I'm going to keep track, or $80 to make. I'm going to keep track of a couple things here. What does that $80 sound like to you? Cost per unit. Thank you. Which would be your slope. And there's something else that you have here. 400 calculators. And that's a profit of $2,000. What's going to be what? What's going to be dependent? What's going to be independent in this relationship? Nice. Thank you, Jalen. So we got 400 is the independent, 2,000 is the dependent. There's a couple different ways you can solve this one. Kind of depends on you. One of the things I suggested that you know was this formula, y minus y1 equals m times x minus x1. You've got everything you need right there to solve. So let's check that out. Your m is 80. That's going to go here. Your y1 is 2,000. That's going to go there. And your x1 is 400. That's going to go there. You've got everything you need. So let's put that in. Y minus 2,000 equals 80 times x minus 400. So y minus 2,000 equals 80x minus 32,000. What do I have to do to solve for y? How about add 2,000? To get y by itself, I'll add 2,000. You can do that on a calculator if you like, but you should end up with y equals 80x minus 30,000. Two more little pieces to go here. Are we okay with this one? The alternative that you could have done to this is you could say, well, y equals 80x plus b. And you know some values of x and y. Those are right here. So that's going to be 2,000 equals 80 times 400 plus b. That's 32,000. If I subtract 32,000 from both sides, I end up with negative 30,000 equals b. Be careful not to celebrate and just leave it there. The final answer that I'd be looking for is 80x minus 30,000. But that's a different way that you can solve the same problem. It's up to you what you find most convenient. I like the first one, but the second one works just as well. What does it mean to have a break-even point? What do I mean by the break-even point in producing those calculators? What should be your profit if you break even? 0. So if I want to find the break-even point, that's going to mean the profit is 0. Profit equals 0, so that means 0 equals 80x minus 30,000. Let's move the 30,000 to the other side. And then solve. 30,000 divided by 80 is going to be 3,000 divided by 8. That should go in evenly, I think. Yep, 375. So 375 calculators, that's where you start to break even. Oh, that's exactly where you start to break even. If this turned out to be a decimal, it was 37.1, then the answer I want to see on your test or your quiz would be 376. Because until you get to that next calculator, you can't produce a part of a calculator. Until you get to that next calculator, your profit is 0. If you want a profit that's actually positive, then you want to round up. If you want to keep it negative, then I guess you could round down. Last but not least, how much profit from 500 calculators? That's y equals 80x minus 30,000. I'll plug in the 500 there. Plug in the 500. 5 times 8 is 40, and there's 3 zeros. 1, 2, 3. So 40,000 minus 30,000 gives you $10,000 profit. Whew! Yay. All right. A little bit fast, but I think we're okay there. Any questions or anything like that on these review problems? Awesome. Let's put this one on YouTube.